Hi friends, this is Ekadishar on your very own channel Classes with Aidar. Today's topic is mole concept and the related problems. You know, mole is a unit which stands for 6.02 into 10 to the power 23 entities of a substance. This number is also referred to as Avogadro's number, named after the Italian scientist Lorenzo Romano Amedeo Carlo Avogadro. He introduced this in the year of 1811. Here, the entities means particles which can be, atom, molecules, electron, proton, neutron, ions, and so on. This number 6.023 into 10 to the power 23 is also denoted by an A. Now look at the board. We are taking example of oxygen. Oxygen has got a symbol of O, whose atomic number is 8, whose RAM means the relative atomic mass is 16, and RMM means the relative molecular mass is equal to 32. Just got no unit, 1 mole of oxygen atom, that will be equals to 6.023 into 10 to the power 23 number of atoms of oxygen. We call it 1 gram atom, and which is in mass 16 gram. Likewise, 1 mole of oxygen molecule, that equals to 6.023 into 10 to the power 23 number of molecules of oxygen, that is equivalent to 1 gram mole, or we call 1 gram molecular mass, and that is equivalent to 32 gram. Similarly, we know that 1 electron has a charge of 1.6022 into 10 to the power minus 19 coulomb of charge. So, 1 mole of electron will have a charge equals to, just to multiply 1.6022 into 10 to the power minus 19 into 6.023 into 10 to the power 23. Just if you calculate, it comes down to 96,500 coulomb. That we called 1 Faraday, after the famous scientist, Faraday. It is called to be 1 Faraday. Now take the example of water. Water has got a formula of H2O, or dihydrogen monoxide. Its RMM is the relative molecular mass is equal to oxygen 16 and hydrogen 1. So 1 into 2 plus 16, that equals to 18. It has got a unit. That is the gram molecular mass. Gram molecular mass will be 18 gram. Now 1 mole of water will contain 6.023 into 10 to the power 23 number of molecules. That is, it contains 2 into, there are 2 hydrogen atoms, So, 2 into 6.023 into 10 to the power 23 number of hydrogen atoms, and 6.023 into 10 to the power 23 number of oxygen atoms. That is 1 liter or 1000 ml, means 1 milliliter of water has a mass of 1000 gram. That is, it contains 1000 by 18, that equals to 55.55. It continues mole of water. That is the number of mole of water in 1 liter or 1 kg is 55.55 moles. Note, the number of moles of a substance, it's a formula you can remember. It's easy to remember also. Its mass taken in gram upon its gram molecular mass. Now take an example, a practical one, On your birthday, you got a gift of a diamond ring. The diamond has a mass of 1.8 gram. And the question is, how many carbon atoms you are gifted with? How many carbon atoms you are gifted with? It is given that the RAM, that is the relative atomic mass of carbon, is 12. You know that relative atomic mass has got no unit. Okay? You want to do this sum? No, it is so easy to answer, dear, if you have the concept already built up. Gram atomic mass of carbon, what is that? The RAM expressed in gram, that equals to 12 gram. So, what is the mass of the diamond that you have been gifted 1.8 gram, and the gram atomic mass of carbon is 12 gram. So this gram cancels out, and that is the number of moles of carbon. Number of moles of carbon. And you friends are knowing that diamond is nothing but the carbon to a chemist. A chemist has got the value of a diamond in the terms of the carbon, nothing else. Okay. Now what is the question? The number of carbon atoms that you were gifted with. So how could you get it? This is the number of moles of carbon that you have been gifted, and 1 mole of carbon is containing the Avogadro number of the atoms. Therefore, the number of carbon atoms in your diamond, number of carbon atoms in your diamond, it is 1.8 upon 12 into 10 to the power 23, 6.023 into 10 to the power 23. This is the Avogadro number, 23. You can easily calculate it out. Just you calculate, and I am giving you the answer, I am giving you the answer. This will be 9.0345 into 10 to the power 22 numbers. Okay? A big number of carbon atoms you have been gifted with. Okay, it's a very funny question. You have got the answer now. Now, let us take another illustrative question. Density of water at room temperature is 1.0 gram per milliliter. The question is, how many molecules are there in a drop of, the hammer drop of water, whose volume is about 0.05 milliliter. This is your question. So what is your question? How many molecules are there in a drop of water? So I can answer it. What is that? A drop of water has got a volume of 0.05 ml. So its mass will be 0.05 upon 1 gram. Okay, milliliter of water is equivalent to 0.05 by 1 gram, that equals to 0.05 gram of water. Now what we have to find out how many molecules are. Now why don't you try to find out the number of moles that is there in 0.05 gram of water. So you just have divided with the gram molecular mass of water. So it is 0.05 gram by 18, and what that will be, I do not know. That is 0.05 by 18 number of moles. Now as you are knowing that 1 mole of water molecule has got the molecule of the Avogadro number. So this number of moles, what is the number of molecules it is going to have? It will be 0.05 upon 18 into 6.023 into 10 to the power 23 number of water molecules. So simply calculate and you get the answer. Simply calculate and you get the answer. Okay? The answer will be 1.67 into 10 to the power 21 number of water molecules. So this is done. Now take the example or another question that was set in the IIT entrance test in the year of 1972. Now take care of. Okay, this is the question. A 2-liter glass vessel. So a 2-liter glass vessel contains nitrogen and water vapor in equimolar proportions at a pressure of 10 to the power minus 3 millimeter of mercury at temperature 303 Kelvin. Now what is the question there, The question is the number of moles of nitrogen in the water vapor present, number 1. Number 2 is the total mass of the gaseous mixture, right? And find the mass of the gas when the mixture is cooled to minus 50 degree Celsius. What is given? The value of R is given, that which is 0.082. It is given to you. Now think for a while. Okay. Now here you have to you will use the concept of the ideal gas equation that you have read in your gas chapter, that which says PV is equal to nRT, where P is the pressure of the gas, V is the volume, N is the number of moles of the gas present, R is the universal gas constant, and T is the temperature of the gas in Kelvin. Thereupon, we have to find out N, that is the number of moles of the gas that culminates to PV upon RT, right? Now what is given? It is given that the pressure of the gaseous mixture, that is your nitrogen and the water vapor, that was 10 to the power minus 3 millimeter of mercury gauge. And you know 760 millimeter of mercury gauge is equals to 1 atmosphere. We have to convert it into atmosphere. Therefore, P 10 to the power minus 3 upon 760, it is the atmospheric, it is the pressure of the gaseous mixture in atmospheric pressure terms. The volume has been given, it is 2 liter. The number of moles of the gas, we have to find it out, that is the question, and R equals to 0.082. Though the unit is not given, it will be liter atmos per mole Kelvin. Okay. Now just place it into the equation. So N equals to 10 to the power minus 3 into 2 divided by 760 into 0.082 into 303. That, if you calculate it out, it will be 1.059 into 10 to the power minus 7. So the first part of the question is answered. Now coming down to the second part. It is given that the mixture is an equimolar mixture of the nitrogen gas and the water vapor. Okay. Because it's an equimolar mixture, so number of moles of nitrogen is very much equal to the number of moles of the water vapor. Okay. That is, it will be having half into the total, that is 1.059 into 10 to the power minus 7 number of moles of gas. Now that was not the question. The question was, what is the total mass of the gas mixture? Okay. So total mass of the gas mixture means the mass of the nitrogen plus mass of the water vapor in the mixture, and that equals to mass of the nitrogen. The number of moles, half into 1.059 into 10 to the power minus 7, and the molecular mass of nitrogen, that is 28, plus half into 1.059 into 10 to the power minus 7 into 18. 18 is the molar mass of water. So if you work it out, then it comes to 24.357 into 10 to the power minus 7 gram. Now the last part of the question was, if the gas mixture is cooled down to minus 50 degrees Celsius, what will be the mass of it? Now my friends, it is quite clear that at minus 50 degrees Celsius the water vapor will condense down to the water. That doesn't constitute the gaseous mass, and thereupon this part will be nullified. Only this will be the mass of the nitrogen, and that is that 1 by 2 into 1.059 into 10 to the power minus 7 into 28, that which will be equals to 14.826 into 10 to the power minus 7 gram. So at minus 50 degrees Celsius, this will be the mass of the gaseous mixture, right? I hope you enjoyed the class, and here we end this session of the mole concept and related problems. Now there, I will be urging you to like, subscribe and share my channel. It is your channel also. Okay. Thank you.